So let's take a look at an algebra question from the Leaving Cert Higher Level 2014 Sample Paper 1. It's question 3, and we're given a cubic function, f of x is equal to x cubed plus 1 minus k squared x plus k. We're asked to show that minus k is a root of f. So if x equals a is a root of an equation, then the f of a should be equal to 0. So what we're going to do is we're going to sub in x equals minus k into our cubic equation, and c is the result 0. So the f of minus k would be equal to minus k cubed plus 1 minus k squared times minus k plus k. Multiplying this out, we get minus k cubed is minus k cubed. Then we have 1 times minus k is minus k. And minus k squared times minus k is plus k cubed plus k. And we can see that minus k cubed plus k cubed is 0, and minus k plus k is 0, giving us a result of 0. And this means that x equals minus k is a root of our cubic equation. Again, the factor theorem says that if x equals a is a root of an equation, then x minus a is a factor. And so we know that x equals minus k is a root of the equation from part A, so x plus k must be a factor of the equation. And so if we divide x plus k into our cubic equation, we'll be left with the quadratic equation we can solve to find the other roots. So I'm dividing x plus k into my cubic expression, which is x cubed. I'm going to leave a space for the x squared component, plus 1 minus k squared x plus k. So we start the long division by dividing x into x cubed, which gives us x squared. Once we place the number up here, we're going to multiply x squared by x plus k. X squared by x gives us x cubed, and x squared plus k gives us kx squared. We draw a line underneath, and we're going to subtract the bottom line from the top line. So minus, minus. X cubed minus x cubed will cancel, and then we have minus kx squared plus 1 minus k squared x plus k. We repeat the process. We're going to divide x into minus kx squared now, giving us minus kx. Minus kx by x is minus kx squared. Minus kx by k gives us minus k squared x. We draw a line underneath, and we're going to subtract the bottom line. So we change both the signs. Minus kx squared plus kx squared cancels, and then 1 minus k squared x plus k squared x will leave us with x. And then we have plus k. One last time, we divide x into x, and we get 1. 1 times x is x, 1 times k is k. We draw a line underneath, and we subtract the bottom line, so we change both the signs. X minus x is 0, k minus k is 0, and so we have a remainder of 0 in the question. So if x plus k is a factor of our cubic expression, then x squared minus kx plus 1 is another factor. And so to find the other roots of the equation, I'm going to write that x plus k, one of our factors, multiplied by our quadratic factor, x squared minus kx plus 1 equals 0, and solve for x. I already know that x plus k is equal to 0, yielding x equals minus k as one root. And to solve for x squared minus kx plus 1 equals 0, I'm going to have to use the quadratic formula in the tables. So x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. A is the coefficient of x squared, which is 1. B is the coefficient of x, which is minus k. And c is the term independent of x, which is 1. So subbing these into the formula, we have x is equal to minus b, which is minus k, plus or minus the root of b squared, which is minus k squared, minus 4 times 1 times 1, all over 2 times 1. Tidying this up, we have minus minus k is plus k, plus or minus the square root of k squared, minus 4 by 1 is minus 4, all over 2. And so our other two roots in terms of k are k plus the root of k squared minus 4 over 2 and k minus the square root of k squared minus 4 over 2. The C part of the question then says to find the set of values of k for which our function has exactly one real root. We know it's a cubic function, and so it rises and then falls and then rises again. And if it has exactly one real root, well then it crosses the x-axis in one place only. And we've already found out that the value of this root is minus k. So if minus k is the real root, then k plus or minus the root of k squared minus 4 over 2 are non-real roots. And if they're non-real roots, then their discriminant, k squared minus 4, is less than 0. We've already calculated the b squared minus 4ac to be k squared minus 4. And so this has to be a negative number, less than 0. To solve this quadratic inequality, we're going to find the critical values by letting k squared minus 4 equal 0. If k squared minus 4 equals 0, then k squared is equal to 4, and k is equal to plus or minus 2. To determine the nature of the signs, we're going to draw a quick quadratic sketch. So k squared minus 4 is u-shaped, and we've established that it cuts the x-axis at minus 2 and plus 2. We're looking for values of k such that k squared minus 4 is less than 0, values that are underneath the x-axis. So the solution will be k values that lie between minus 2 and 2. So minus 2, less than k, less than 2 will be the set of values for which the function has exactly one real root.